Welcome to the third video in our 6-4 video series. In this video we're going to specifically look at how to convert into intercept form. So to convert a quadratic into intercept form, we will first need to be able to factor the function. Now we're already used to factoring quadratics that are written in standard form, and if you need to review this, go back and check out lesson 5-3. The little tip was a little bit off, there was a typo, it said 5-2, but if you just change that to a 5-3, you'll be looking in the right place. But to be able to factor something that is in vertex form is something that's a little bit new to us. And actually, to be able to do that, we will first need to convert it into standard form, which we talked about in video 1. So what I'm going to do is I'm going to do example 5, and I'm going to convert this first from vertex form into standard form. So remember, to convert to to standard form from vertex form, we have to expand our parentheses there. The x minus 3 squared is going to be rewritten as x minus 3 times x minus 3. And then I have the plus 4 at the end. I want to make sure that I bring down that negative sign. And then I'm going to go ahead and distribute my binomial times my binomial. That's going to give me x squared minus 3x. And then I do the same thing with the second term and get a negative 3x minus 3. Remember, I want to make sure that I put those parentheses around it so that I can keep track of any distribution that I'm going to need to do. I'm going to still bring down my negative, and I'm going to combine like terms. So that's going to give me x squared minus 6x. And I did make a typo here, so let's go ahead and correct it. Hopefully you notice this on your own. But a negative 3 times a negative 3 is not just negative 3. It's actually a positive 9. So make sure that you fix that if you didn't catch it along the way. And then we're going to fix that by carrying it down here, and then carry down the plus 4 at the end. We now need to distribute that negative sign to all three pieces. So that's going to give us f of x is equal to negative x squared plus 6x minus 9 plus 4. Alright, so now that I have distributed that, I can combine everything else. So that's going to give me negative x squared plus 6x minus 5. And so now I'm going to come over to the side. I have it in standard form now. And what I'm going to do now is focus on changing it into intercept form. Now, just to give you a reminder as well, if you were to be given standard form and need to change it to intercept form, you would just pick up from this point in the process. So to be able to factor, we need to have a positive a value. So it's going to seem a little contradictory since we distributed the negative 1 earlier, but we are going to pull out a negative 1 as our GCF, and that's going to allow us to factor, because remember, we don't want a negative a when we factor. So that's going to be an x squared minus 6x and a positive 5. So the next thing we need to do is go ahead and factor this. Now, I am going to keep that negative 1 in front, and I'm going to set my two sets of parentheses. I'm going to check, and I am going to see the x, or my first term, my a is prime, so that lets me lock in the x and the x. I look at my signs, I see a plus sign on my c, so that means I'm either going to need a positive positive or a negative negative. When I look at the sign on my b value, I see that that's negative, so I want these to both be negatives. So I'm going to lock in my negative signs. Now, to get 5, we only have two choices, 5 and 1, because 5 is prime, so that's going to make this a pretty easy problem to factor. Both of these are the same, so it's not going to matter which order I put them in. And so I have my factored form. I'm going to rewrite this as a negative, and then it's going to be x minus 1 times x minus 5. And I have changed something from vertex form into standard form and then into intercept form. So you guys make sure to give the U-try an attempt and then come back for our final video in the 6-4 video series. See you guys then.